Ever wondered why winter is so cold? Have you heard of the polar vortex or jet streams? These natural phenomena play a significant role in shaping our winter weather. Let's start with the polar vortex. Imagine a gigantic whirlpool of frigid air spinning counterclockwise at the top and bottom of our planet. This is the polar vortex, a vast area of low pressure and cold air that encircles both of Earth's poles. It's like a colossal climate donut where the filling is the coldest air on Earth. In the summer, this vortex weakens, but come winter, it strengthens and expands, often driving cold air southward with the jet stream. This is why we experience those bone-chilling winter outbreaks in regions like the United States, Canada, parts of Europe and Asia. Now you might be wondering, what exactly is a jet stream? Picture narrow bands of robust wind blowing from west to east, weaving their way around our globe like a massive atmospheric conveyor belt. That's the jet stream for you. There are 4 primary jet streams on Earth, 2 near the North and South poles, known as the polar jet streams, and 2 closer to the equator, known as the subtropical jet streams. But how do these jet streams form? It all comes down to the sun and how it doesn't heat the Earth evenly. Areas near the equator are toasty, while areas near the poles are frosty. When these warm and cool air masses meet, the warm air rises and the cool air sinks, creating an air current or wind. These jet streams form high in the atmosphere, at the boundaries where hot and cold air meet. They are most pronounced during winter and can move at an average speed of about 110 miles per hour. So the next time you feel that chilly winter wind, remember it's the polar vortex and jet streams at work. The polar vortex isn't just a fancy term, it's a complex system with significant effects on our climate, especially during the winter. Now let's dive into how this all works. Picture this. The polar vortex is a massive area of low pressure and cold air that encircles both of Earth's poles. This vortex strengthens during the winter months and weakens during the summer. But why is that? Well, it's because this vortex is driven by the contrast between the cold air over the poles and the warmer air over the equator. The term vortex refers to the counterclockwise rotation of air, which helps keep the colder air locked near the poles. Now, imagine a spinning top. The faster it spins, the more stable it is, right? That's similar to the polar vortex during the winter. It's strong and stable, keeping the cold air confined to the poles. But here's the interesting part. During the winter, the polar vortex occasionally weakens and wobbles off its axis, causing it to expand. This expansion sends a rush of cold Arctic air southward with the jet stream, a narrow band of strong winds high in the atmosphere. This phenomenon occurs quite regularly during winter in the northern hemisphere. It's often associated with large outbreaks of Arctic air in the United States and Canada. So, those chilling winter days, you can thank the polar vortex for that. But it's not just North America that feels the effects. Portions of Europe and Asia also experience these cold surges connected to the polar vortex. It's like a winter postcard delivered right from the Arctic. The reach of the polar vortex is impressive, extending from the tropopause, the dividing line between the stratosphere and troposphere, through the stratosphere and into the mesosphere, which is above 50 kilometers. The air inside the vortex is associated with low values of ozone and cold temperatures. So the polar vortex doesn't just stay at the poles, it travels, bringing the chill of the Arctic to our doorsteps. Now you know about the polar vortex, but what about jet streams? These powerful air currents also have a hand in shaping our weather. Jet streams are like the highways of the sky. They're narrow bands of robust wind that typically blow from west to east, right across our globe. And guess what? We have 4 primary jet streams on Earth, 2 polar jet streams near the North and South poles, and 2 subtropical jet streams closer to the equator. But how do these jet streams form? It's all about the meeting of the warm and the cold. The sun, our life-giving star, doesn't evenly heat the Earth. That's why we have hot equatorial regions and cold poles. So when the warm air masses from the equator meet the cold air masses from the poles, something fascinating happens. The warm air, being lighter, rises higher in the atmosphere, and the cooler air, being denser, sinks to replace the warm air. This movement creates an air current or wind, and voila, a jet stream is born. These jet streams, these air currents high in our atmosphere, are most pronounced during winter. That's when the boundaries between hot and cold air are most defined. So during both the northern and southern hemisphere winters, these jet streams are the strongest. Imagine a river flowing at about 110 miles per hour. That's how fast these jet streams move, shaping our weather patterns as they go. They're located about 5 to 9 miles above Earth's surface in the mid to upper troposphere. That's the layer of Earth's atmosphere where we live and breathe. So the next time you wonder about the weather, remember the jet streams, these rivers of air high above us. They're a significant player in the grand scheme of things, silently shaping the weather we experience on the ground every single day. Jet streams are like the rivers of the sky, flowing with air and influencing our weather. Both the polar vortex and jet streams have a significant impact on our winter weather. We've journeyed together through the fascinating world of these atmospheric phenomena. The polar vortex, a vast, low-pressure zone of frigid air encircling our Earth's poles, ebbs and flows with the seasons, often extending its icy reach to the south during the northern hemisphere's winter. This expansion can result in severe cold outbreaks in the United States, Canada, parts of Europe, and Asia. On the other hand, jet streams, swift air currents high in our atmosphere, are birthed from the meeting of warm and cold air masses. These powerful air streams, the strongest during winter, generally blow from west to east across the globe, influencing our weather patterns significantly. Understanding these phenomena helps us comprehend why our winters are cold and what influences our weather patterns. So, the next time someone asks why it's so cold, you can tell them about the polar vortex and jet streams.